Good evening. Good evening to all. Good morning to Dr. Gallo. Today is the fourth day. First day we have discussed on variants of COVID variants. Second day mainly focused on vaccines, and the third day post-COVID treatment and management. Today our focus is on future COVID-19 and other pandemics. For predicting future, we have to look backwards and understand history. The further we look backward, the further we can go forward. And throughout the history, nothing has killed more human beings than infectious disease. It was not natural disasters like earthquake or volcanoes. It was not war. Man-made disasters killed more human beings. It was infectious disease. COVID-19 marks the return of the very old and familiar enemy in history, the infectious disease pandemics. And going back to history, before Neolithic period, there were no epidemic. It was not a problem in Earth or human beings in Earth. During that period, they lived in small groups or clans or maybe 20 to 40 individuals. And if there is an outbreak, they all die off. There is no transmission to others. They live nomadic as hunters, gatherers, or fishers. And small groups of people seldom met other groups. And about 10,000 years ago, 12,000 years ago, that is 10,000 BC, when people began to domesticate animals and start cultivation, store food, and establish farms and cities, they become agrarians. They started to communicate and trade with each other, and this paved the way to epidemics and pandemics. And along with this, when they communicate and trade each other along the globe, long distance journeys, trade, or migration through by ships or hordes paved the way to pandemics. And mainly the animal domestication historically created favorable conditions, and this domestication favored conditions for animal microbes to thrive and adapt among human beings. And there is genotypic evidence that today we are having evidence that measles and tuberculosis and smallpox are evolved from cattle, and influenza from pigs or ducks, and pertussis from pigs. And as they grow, animals grow, human beings grow, they grow with mixed population. Along with this, these microbes grow and in numbers as well as in density. The oldest records available about epidemics are from China. The latest pandemics are also originated from China also, latest COVID-19. From 243 BC, for the 2,000 years, we have got historical evidence from China. More than 500 epidemics or pandemics are originated from China. The records are available. And the history of outbreaks showed that a striking correlation between growing population as with growing population and frequency of epidemics. Along with the population growth, the epidemics are growing. Along with there is mixing of human and animals. And for understanding the dynamics and spread of epidemics and pandemics, the correlation between growing size of population and the increasing frequency of outbreaks is important. And as per the modern history recorded, first the pandemic was plague in 6th century, known as Justinian plague, which killed almost 50% of the world population. And second, also due to plague in 14th century, Black Death, it killed 20 million people in Earth. And during the Black Death, it mainly the Venice is a port, main trade center of the world, and it was realized that only solution was separating people or suspected sick people who was isolated into islands in the Venetian lagoon, and they are kept separated for 40 days. From this, the quarantine, the word derived, and now we owe the English word quarantine from Italian 40 days. In 20th century, again smallpox killed more than 30 million population. Next, in the century, recent centuries, cholera epidemics, 8 pandemics. Now we are living in the 8th pandemic. The first pandemic originated in 1817 in our own Ganges Delta belt. The last pandemic, the 8th pandemic of cholera, is 1992 from Bengal itself. And coming to this last century, it was mainly due to influenza viruses. During First World War, 1980, the Spanish flu influenza pandemic. It started in United States, even though it was started in United States and spread along with the soldiers. It was known as Spanish flu because the Spanish language was printed as news and came. It was brought to outside world. News was outside world in Spanish paper, and it caused death to more than 100 million people. And after Spanish flu, there are Asian influenza flu, Hong Kong influenza, and in 1980, since we are having HIV pandemic, that is still living with us, and people are living with HIV also, and it is estimated to kill 75 million people, and 32 million estimated people are killed. And today we have got the guest, Robert C. Gallo, who discovered that virus. Very great contribution to humankind he has given. And what are the advantages of these pathogens or the viruses? Mainly, most of the pandemics are due to viruses, and the pathogens make effective mass killers because they are self-replicating. And in the war, the bullet that kills in a war must be fired and must find its target. But in the case of pathogens, no firing needed, no targets needed. An infected person will fire itself, and due to the symptoms, sneezing or coughing or bleeding, it will transmit to other human beings. And also, in natural calamities, disasters, it is constrained in this particular area. Earthquake strikes in China will not directly hurt UK, but the virus and the pathogens can. They can propagate. And in the host, it will act as a manufacturing unit. The infected person will become a manufacturing unit, and he or she will transmit due to this his or her symptoms. And when due to human behavior, when they move around and interact with other people, there is automatic transmission of disease. So during 1962, we are in the euphoria of discovering so many antibiotics. And during that year, Sir Frank McFarlane Burnett had got Nobel Prize. And when he was asked to write about the infectious disease, he told that write off something that has passed into history. The infectious disease is write off from the history, and that was a good news, but it was only a bad optimism. Now, as a bad news, the COVID-19 reminds us that infectious diseases haven't vanished. And during the last 50 years, the infectious diseases like SARS, HIV have fourfold increase. And over the last 20 years to 21st century, we have got Nipah epidemic in 1999, SARS in 2003, H1N1 in 2009, and MERS in 2012, and Ebola in 2016, and lastly, we are living with the COVID-19. Why there is this pandemic or epidemic? One is we are more human being increase in numbers. There are more livestock increase in numbers. There are more mixing. And along with this number increase, we are exploiting the environment. And during this process, the agents, this is causing agents, they will mutate. We are creating possibilities. And when the number increase, we will exploit more natural resources for agricultural activity. The land use pattern is changing, and the antibiotic misuse due to greed, the pig killed the ducks laying golden eggs, Now 50 to 60% of the manufactured antibiotics are used for treating animals, not treating, but for poultry industries, and trade, travel, tourism. They are act as escalators for this mutated virus. And also the speed of travel is increasing. Within the incubation period, we can go 2 times around the globe. So all are swimming in the same sea of microbes. So these ecological changes are opportunities for vectors as well as zoonotic spillovers. Now the most 70% of the new emerging diseases are due to zoonotic spillovers. So main cause is as epidemiologists are seeing, most of the disease causing are zoonotic agents, mostly due to anthropogenic activities. This is about my introduction about the topic. And next, I want to introduce our chief guest, Dr. Robert Charles Gallo. He needs no introduction for this audience. For the sake of formality, I am introducing. He is eminent US scientist who became the world famous when he discovered that HIV virus was caused by AIDS. AIDS is caused by HIV virus. He and his team in 1980s discovered HIV virus. And prior to AIDS epidemic, Gallo was the first to identify human retrovirus and only non-human leukemia virus, HLTV. And in 1976, he and his colleagues discovered interleukin-2, which is now used for therapy for some cancers as well as sometimes used for therapy of AIDS. For the first time in early 80s, he also pioneered and development of HIV blood test, which enabled healthcare workers to screen for HIV, leading to more rapid diagnosis, thus protecting patients receiving blood transfusions. His research also helped physicians to develop HIV therapies to prolong lives of those infected with virus. In 1980s, he and his group discovered the first new human herpes virus, HHV, and more than 20 years later, it was shown that it is the cause of infantile roseola. And currently, it was hypothesized that it is a strong suspect that it is the origin of multiple sclerosis due to this virus. And in the next decade, 1996, his discovery that the natural compound known as chemokines can block the HIV virus and halt the progression of AIDS. It was hailed by Science magazine as one of the year's most important scientific breakthrough findings. And as a career, after completing his medical residency at University of Chicago, he became the researcher at National Institute of Cancer Institute. Here he worked for 30 years, mainly as a head of laboratory of tumor cell biology. It was said that Gallo states that his choice of profession was influenced by his early death of his sister from leukemia, a disease to which initially dedicated much of his research. He's mainly worked on cancer and leukemia due to dedication of his late sister. And 1996 onwards, Gallo is the director and co-founder of the Institute of Human Virology at University of Maryland School of Medicine, Baltimore. And Gallo is also co-founder of biotechnology company, Profectus Bioscience. And also he is a co-founder and scientific director of Global Virus Network. We have Dr. M.V. Pilla have described the work of Global Virus Network on the first day. And main work of this Global Virus Network is increasing collaboration among virus scholars and expanding virologist training programs and overcoming gaps in the research, especially during early stages of viral epidemics. And as a part of this network, he visited Kerala in Trivandrum in, I think it is 2011. Gallo was the most cited scientist in the world from 1980 to 1990 decades. Most cited scientist in the world. And he has published over 1,300 papers, more than that. And he has got 19 honorary doctorates. And so many awards he got. The prestigious award was twice he got the Lasker Award. First is for pioneering studies that led to the discovery of first human RNA tumor virus in 1982. 1986, also second, he awarded second Lasker Award for determining the retrovirus, known as HIV as the cause of AIDS. And he is the only recipient of the 2 Lasker Awards. So today we are blessed with the one of the eminent scientists ever lived in Earth with us. We are I invite him, Dr. Gala, to deliver his talk on this topic, reflections on epidemic and pandemics. Over to sir for your presentation.
Thank you very much, Dr. Theo, for the detailed and very generous words. And I also thank some kind words also from the Vice Chancellor, Dr. Kunamal. It is awkward, and I hope you don't take it as talking about myself, but I have to mention one correction and one omission. In scientific awards, I believe, Dr. Theo, you might wanted to recognize that the Birla Prize of India was one of the first awards I have received back in the early 1980s. It's a long time ago, but I remember it very fondly. And the poor universities that gave me a doctorate, not 19, but 35. So you have me as a much younger man, Dr. Theo. This is a while ago. So I got an old biography that you must have received. Okay. So anyway, I hope you didn't mind that very slight correction and self-serving statement by me, but I could not omit the Birla, for example. So, I will have a few comments, reflections really on epidemics and pandemics. And Dr. Theo gave a really wonderful overview of the history of these serious infectious diseases in a capsule. I don't think anyone could do it better. To give it summary so complete in just a few minutes. However, I want to do some of that, but I want to emphasize, I will be more strict about epi and pandemic. I take the word pandemic literally, that it has to involve the world. Therefore, it's fewer in number, but I'd also like to mention some epidemics and as well. And when we start, I would like to show you at the beginning the outline. So I'd like to give some general thoughts on pandemics that will overlap and agree with Dr. Theo. I'd like to tell you a little bit of experiences with HIV and then make some comments on what I see as the success of SARS-2 and its failures. Strangely, and giving equal and greater time, I would like to emphasize the role of not just of the successful specific vaccines that induce innate immunity, but then go on to make adaptive immune response. The typical specific vaccines like we have, such as the messenger RNA vaccines and other vaccines for SARS-2. I'd like to spend moments on just innate immunity, where you have stimulation by a wide variety of things and how important it really is, and how we have to think more about it at the beginning of a pandemic or epidemic. And that would get us into and lean to and join to preparation for the future. And with that, I'd also like to tell you a little bit more about the Global Virus Network, which I think could be useful. And I want to say from the beginning, no place in the world is more important to the Global Virus Network than India, because of population, the large population of people, the great talent in biomedical science that is in India, and a lot of it not sufficiently tapped by the world. And the fact that sometimes infectious diseases are very important in the subcontinent. And it's why we've placed extra importance on India for the Global Virus Network. And I hope in the future, you really will play a leadership role in the next years to come in this organization. And we will come back to it at the end of this talk. In my view, there have been 4 great pandemics in the past 100 years. The flu of 1918, 1919, which you heard described already. Not mentioned though, polio of the 1950s. HIV of the late 70s, 80s began. I mean, it actually began much earlier, but when we became aware of it was at that time. And then, of course, the SARS coronavirus number 2. And a horrible mistake on my slide, I say 1919. Oh, somebody's on my speaker. Of course, that should be 2019. That's a mistake. Who's ever on the phone, can you mute, please? Because you'll interfere with my thinking. Thank you. Okay, so the last 2 are still ongoing. And I want to tell you what I think are in common with these pandemics of the last 100 years. I don't want to go further. There's pandemics that were bacterial. There are pandemics, DNA virus. I mean, smallpox. I'm not going to mention any of that. This is the last 100 years. So we have some things in common. The first is that they tend to occur with about 1 generation apart, about every 25, 30 years. I don't think that has much scientific meaning, but it is a fact. And there have been many epidemics in between or at the same time. So all these pandemics and most epidemics of the current period are due to RNA viruses. That's what's common: SARS, MERS, chikungunya, various strains of influenza virus, Ebola, Zika. All these are caused by RNA viruses, as well as the 4 great pandemics. They have some other common characteristics: high rates of replication, as such, high mutability, and as such, easy to transmit except for HIV. That stands out as the unique exception, despite the fact that among all these viruses, it is the most variable. It is the most variable virus I think we've ever seen. Okay, so they have these things in common. Of course, they have differences. People have asked me many times about the similarities between HIV and this virus. And there's no way to make that kind of comparison. Of course, they have things in common and some common lessons related to public health, but every virus has to be dealt with individually. It has unique characteristics, and particularly HIV, a chronic virus, a permanent infection, versus these acute viruses. I sometimes am amused by statements coming from some virologists today. Oh, how fast we made progress on things like SARS and MERS compared to HIV was much slower. That's because of our greater technology. Yes and no. Of course, there's greater technology, easier stuff. But HIV was far, far more complicated. It was a mysterious disease of unknown origin. And finding it was harder. There's less virus, and et cetera, et cetera, et cetera. And when you have 100 infections, how do you prove which one is the cause? It presented a much different problem. And you can't just find it dripping out of the tongue of something. I don't consider the discovery of acute viruses any kind of discovery at all. They're obvious. I mean, it's obvious. You can't say I discovered MERS or I discovered coronavirus or something. They virtually drip off the tongue, right? I mean, anybody can find such a virus. So it's not really a discovery. It's a public health problem and you work on it. You don't have to prove its cause. It's obvious. You get infected, you get disease right away. The virus is all over the place. So it's very, very different. I have no patience with hearing with these, these kind of comparisons or similarities. And now I raise another question, another thing I think is common. I think it's common that we forget. No one in this audience, and myself included, would think we'll ever forget SARS-2, the current pandemic. But when I think of it scientifically and rationally and coldly, we will forget it because we forgot everyone. Let's put it this way. We're already forgetting about HIV as if it's all completely solved. And there's 38 to 40 million infected people in the world right now and about 40 million dead. I don't know if SARS-2 will ever reach those kind of numbers. I doubt it, but we already forget HIV. So I think we forget history and lessons from things that occurred before. Let me tell you what I believe. Our memories fade after a generation, somewhere between 25 and 30 years after a full generation. With the great Spanish flu that Dr. Tello mentioned several times, if you read carefully about it, there was another big flu epidemic. I think it was, I don't remember, but it was like something like 1879, 1880. And all the lessons of that tend to be forgotten. If you read the history of polio, for example, a book by David Oshansky, it starts by saying they forgot all the lessons of flu 30 years earlier. I can tell you I was there. We sure forgot all those lessons when HIV came along. We were in America. I can speak what I saw. We were very aware of serious epidemic diseases and the importance of infectious disease in the 1960s when I first arrived at NIH, the National Cancer Institute. But by the 1970s, it was swept away. The common statement was, oh, that's a problem for those people. Not even a politically correct statement, but also not a scientifically acceptable statement that would never be made today, right? You would never talk like that. I used to hear, oh, that's a problem for tropical disease institutes in America, not for anybody else. We have to focus on these degenerative diseases only. And you say, was there evidence for that? Just your statements that you heard statements? Oh yeah, there's evidence. In America, we discarded departments of microbiology in several major US medical schools in that period. So I want to bring to your attention a little more detail on the 1970s. And I called this slide the remarkable biases of the recent past, the 1970s. Well, it's not so recent, is it? I'm getting so mature. It's a half a century ago, and I call it recent. So we get perspective as we get older. So the first was serious epidemic diseases are over in the industrialized world. Therefore, forget it. The second one, which I faced a lot, would not be important to you really, but it was important to me because I was working in this area. Retroviruses do not infect humans, and there are many reasons for this, and they really can't infect humans. So basically, I was told I was wasting my time totally and money of the government. And the third, and I can't give you much evidence for this. Well, the evidence of the second one is the virus cancer program at NIH was destroyed. It was disbanded. I was right at the edge of losing funding and just, not really, not knowing what the future would be. Right at the edge when we discovered the first retrovirus that Dr. Taylor kindly mentioned, HTLV1, that causes leukemia and even a neurologic disease. So I won't have time to go into those reasons. The third was that no viruses cause cancer, and I'll give you the statements for that, or play any role in cancer at any stage of the cancer. This was a conclusion at a meeting organized by the great Jim Watson of Watson Crick fame of a 1974 Cold Spring Harbor Laboratory Conference on the Origins of Human Cancer. That was the conclusion. Yet, in the early 80s, these biases were destroyed. Viruses were shown to be involved in the cause of approximately 20% of all human cancer, and that percent is growing, not getting less. Retroviruses were discovered in humans, as I've indicated, and caused human serious disease, including modest immune abnormalities. But then came one of the great pandemics of history, AIDS, caused by still another retrovirus. The last slide said, how did these developments occur? Well, you can tell this slide is older because it's not for this talk, because there wouldn't be any time. So we're not going to discuss how these developments occurred. When we think about the origin of pandemics, I tend to try to crystallize it into one word. You heard a lot from Dr. Teo on many, related to this point. He gave specifics. I'm not going to give too many specifics, but he talked about the greater populations. He talked about some aspects of mobility and greater amount of animal interactions and so on. When I started to draw these points in my head, I thought about what we see with epidemics, pandemics, is change. Some change occurred. I thought of Rome when the Romans moved to the Eastern Mediterranean. Big epidemics emerged, and they were more than just localized. They did spread, but not to the whole world. With the discovery of the Americas, Columbus brought things back to Europe, and things were brought to the American Indians. A trivial or a small, I shouldn't call it trivial, but a good example, local, obvious example, was so-called Legionnaire's disease in the United States when they had a meeting in buildings that were air conditioned with air conditioning, came a new disease. With the destruction of forests, including right near my house, we have Lyme disease, very common now in America because of ticks that are associated with deer. The deer are in my backyard. At least once a week, I will see some. The Great Flu, you already heard Dr. Teo talk about World War I. And then there's also not just change in a society, but change in a virus. It is believed that polio was a gentle enterovirus, the Coxsackie virus that didn't do much, but a genetic mutation allowed it to be neurotropic, causing polio. After World War II, there were massive social changes, an increase in air travel, tourism, sexual contacts, drug abuse, the insanity of intravenous drug abuse, the medical use of blood and blood products going from one nation to another. Like, for example, Japan did not use blood from its own people, but from Europe and America. All this led to the mobility of a blood-borne virus and a sex-borne virus like HIV and a mother-to-child transmission where bodily fluids were needed. Now, how did we do with SARS-2 so far? Well, this is a tough one because it's so infectious, but certainly easy to find. It took the Chinese, when it appeared, 5 minutes to find it, right? I mean, anybody could find it. And then they published the genome right away in January 10th. Then after that, there were some problems of moving the science in China. And then they maintained some adequate control there, but it certainly spread. It's very, very infectious. But was diagnostics good? Was advice to health people at a local level good? I think overall, worldwide, there was slow and poor leadership. There was a failure of government leadership to a certain extent. And let's analyze what different governments did. They all did something different. Could we follow Boris Johnson's government in England, Trump in the United States, Japan doing essentially nothing? Should we have followed China with much less communication, or Russia? Who do we follow? Which government do we listen to? Sweden, that wanted herd immunity, which does nothing. And we knew that when they were advocating for it. I found no particular government that has showed leadership or with great competence. So I will come back to this, to governments, but I'll say from the start, if I don't have time at the end, we have to have government involved, of course. They have to be funding and they have to provide oversight. But for me, not scientific leadership. That's got to change. Why should we be at the risk of listening to a few people of government involvement in a new epidemic or pandemic? Sorry. I mean, yes, there are some that are very good, and yes, we can listen a bit, but we better have the top scientists we can worldwide communicating and working together effectively. Therapy. Early antivirus specific treatment is again disappointing, still is globally. Yet it's not easy. Remember, we had no therapy for any viral disease, systemic, until HIV. In HIV, you do have time to treat. You do have time to know a person is infected. You can target the virus over a very long period of time. With an acute virus, this is one of the greater challenges for the acute virus. I told you they were nowhere near as challenging for causation and certain other things, but now there's a greater challenge for treating specifically. It's tough because virus moves very quick. So it's going to take intense diagnostic ability and following someone and treating as fast as possible as we get good drugs that are antiviral, which are coming, I believe. There was great variability in government positions here too. Late in the disease, as you all know, we need anti-inflammatory molecules, and some treatments, mostly all of them, were vastly overstated, like hydroxychloroquine, plasma infusions, which made me disheartened because I think it's a 100-year-old therapy. That's what we're doing in America at the beginning. That's what we're doing. And then remdesivir overstated. Dexamethasone is helpful, but I can tell you true advances are coming. there are potent anti-inflammatory molecules that should be coming forth. I'll be very disappointed if this doesn't happen. Vaccines, as you know, so far so good. If we could disseminate them rapidly enough, I would tell you, I never thought the messenger RNA vaccines could work, because I thought wonderful idea. You get the messenger in, it's translated and it's presented properly from within the cell. This would be great. And you can change the sequence according to the variant. Wonderful. But I never thought it would survive. That messenger RNA, as you all know, is easy to degrade. You look at it twice and it degrades. But the breakthroughs in this thing came from the people who developed these protective outer particles, lipids, fatty lipid, fat is redundant, fatty material that gave protection to the particles that the RNA was encapsulated within, that fuse with the cell membrane and allow the messenger RNA to get in the cell untouched. This was a breakthrough. So the only question about these vaccines is longevity. Not the RNA specifically, but anything that targets the spike or the antibodies. We predicted at the start of the pandemic that antibodies would not last against the spike. Why? Because the spike protein has sugar molecules on it that are very similar to what are seen in flu and in HIV and Ebola. And these molecules, for some reason, these glycan shields and these mannose side chains, the B cells that recognize and interact with them are not likely to be those that develop properly into mature plasma cells. My colleague George Lewis is studying this very intently. We don't know exactly the mechanism why they don't, but they don't. And we don't know if we can correct it. We have some funding to try to do so, but I don't know if that will succeed. So we have a problem with longevity of the antibodies. But the good news is that the T cells do last. They last in most things. And it seems, this is premature for me to make a conclusion, but it seems T cells may be helping in the protection. If so, that's important, because that may last. If not, and we rely on the antibodies, I tell you, we're going to need boosts and boosts. And if we have these people that don't want to get vaccinated, they will cause this pandemic to last far beyond than it would have otherwise. And if we don't make sure that the vaccines are available for everyone, this pandemic will resurge and resurge and resurge. So I said at the bottom was their limitation, and we've already discussed that. Now I would like to jump, and it's a jump, to something called innate immunity. And you all know about it. We all have it. Let's discuss it a little bit further. Can we stimulate innate immunity that'll last a little longer than a few days? Yes, we can. You can do this with broadly active, older, well-known vaccines. Broadly active means that they work against virtually anything, but especially other RNA viruses, especially respiratory viruses. These are, you might call, broadly effective, but they are the group of live attenuated vaccines like measles, mumps, rubella. Look at the bottom of the slide, MMR. Oral polio vaccine, live shingles vaccine, not the newer one that's dead, intranasal flu, yellow fever, etc. So many examples of such viruses that are safe and that are more easily available and that are very cheap. Let's compare adaptive immunity with innate immunity. Everybody knows adaptive immunity, but as you know, it occurs secondly after the innate immunity. And the better the innate immunity, the better adaptive immunity you're going to get. So you might ask, what if I have the specific vaccine? Would taking MMR or OPV or something like it be helpful? The answer is yes. It'll make the adaptive immune vaccines, if anything, better, not worse. They don't interfere. So let's look at it. The adaptive immune system is the lymphoid system, of course, mainly B cells and T cells, antibodies, killer T cells, whereas the innate immune system involves mainly the myeloid lineage. And interferon production is key, as are natural killer cells. The adaptive immune response takes weeks to develop. The innate immune response is within an hour. Think about that, very fast. You're going into a dangerous area. You're a soldier. You're a tourist. you're a party goer or whatever. Be nice to have a broadly effective vaccine that works for a while. The next comparison is who has these things? We vertebrates have innate, and of course we have adaptive. We have both. The invertebrates get along fine only with innate. The adaptive immune response is virus specific. The innate immune response is broadly effective. Maybe not as effective, but pretty darn good, what we see so far, what we know so far. The durability of an adaptive classical vaccine, of course, can be long lasting. It can be lifelong, like measles, even HPV is several years. Many of them are, smallpox. These are long lasting. But some, like the attempts to get HIV vaccines or even SARS-2, are not that long, maybe 5 months, maybe 6 months. Maybe even shorter. Look at flu. The innate is always short. You can ask me, well, how long does it last? And the answer is, I don't know. Mihai Netea with BCG says the innate response can last as long as 6 months. But when I check with my colleague, Konstantin Shumakov, he says all we know with oral polio vaccine, for example, and likely also MMR, is how long interferon lasts, and that's about a month. But a month is not to be thrown away. It gives you some time, and you can boost again, maybe get a few more months, right? So I think it's understudied, underfunded, underappreciated. The adaptive immune response vaccines, going back to the left side of the slide, is safety is variable, but the innate is already proven safe, right? You already know from your experience what it is. The adaptive immune response specific vaccines cost money. What does OPV cost? 15 cents. MMR, I can get it in my drugstore for a few dollars. Funding for research, the adaptive is billions. Innate, hardly anything. There's a good reason. And one of the reasons is people don't understand vaccines well. We could just cause confusion. There would be more people not wanting to take them. The argument against it is that there'll be such confusion, it will reign, it will be a problem, et cetera, et cetera. And there is no incentive financially for companies to do it. And companies have to survive. We can't just curse the companies. I mean, they make things possible. They've done a good job, but they can't do it for free. This is a problem. So this is a place for government, but it's also a place for strong education, because the argument against it is going to be, oh, it'll cause all this confusion. Oh, OPV gives polio. The fact is, a few people in WHO have made that statement. In 30 years in the United States, in a vaccinated population, there was no polio whatsoever after billions, not millions, but billions of doses. So in a vaccinated population, there really isn't a hazard. But we don't have to, if they want to blackball OPV, I and my wife took MMR throughout the pandemic every few months. So did many of the leadership of the Global Virus Network. If I had OPV, I would have taken it. We don't get it anymore. Even though between 1960 and 1990s in America, that's what we had. And we did fine. The arguments for the importance of innate immunity in controlling SARS-2, I've already made some, but I'll give you more. Bats harbor coronaviruses and hold them in check by the innate immune mechanisms. I'm going to say that what they do is they have a constitutive but very low level of interferon always there, and a very low level of activated NK cells, and they do fine. But let me ask Dr. Kunumal. He's more than 20 years old. I can see that he's over 20, maybe 22 years old. By this age, how many times have you been infected by a virus that gave you little respiratory problems? Maybe no symptoms at all, maybe feeling fatigue, maybe a chill, maybe a low-grade fever, blah, blah, blah. Many, many times. Why did you get better? You didn't have time for your adaptive immune system. You probably got better in 2 days. How often that happens? It happens all the time. Why do we get better? Strictly our innate immune system. It reacts within an hour and you're better. It's not that the virus decides to go away or that the virus runs out of cells to infect. It's because you have an innate immune system. And I repeat, the invertebrates, that's all that they have. Secondly, on the slide, the genetic information in SARS coronavirus 2 has put a part of its genome specifically to avoid the innate immunity. The NSP1 gene for that protein is almost purely to avoid innate immunity, which tells us that this virus is very susceptible to innate immunity. If you had it there beforehand, it might be the real major trick. Thirdly, the very earliest papers in this field, the very extensive paper from the Stanford group of Balachandra, who, by the way, is from India, originally, his family, clinically better prognosis he showed with his group at Stanford correlates only with strong innate immune response, like interferon, not antibodies, etc. That's just the natural avoidance of doing well or doing poorly. In my mind, durability is the singular advantage of the conventional adaptive immune stimulating vaccines, and they're a little more potent too. I should have said that. Usually, when they work, they're more potent. Not always. Sometimes innate immunity, as shown in a Russian trial, was better with OPV for flu than with the flu vaccines. So, and then higher levels of interferon correlate with better prognosis of SARS coronavirus 2. Okay, what could we think about using? Let's think together about it. I don't have any stock in innate immunity. I don't have stock in anything that's medical. So there's no financial, I'm not consulting to anybody that does anything with innate immunity. I have no advantages here. Let's think together. Well, where could this be useful if this is right? And what I told you so far is right. No one can debate that. I would think at the beginning of any new epidemic or pandemic to fill in the gap between the appearance of the new epidemic and developing the effective specific vaccine, which usually takes at least 2 years, and sometimes, like HIV, forever more. They're still not getting anywhere. For countries that cannot gain access to the specific vaccine, even within that period, where years are going by, why don't we use it? And if there's a problem with durability, or if there's a problem with inability to handle variants that emerge. And finally, you might think of using it together anyway. Couple the live attenuated vaccines with the specific vaccines. They may make those vaccines last longer and have greater potency. I don't know that, but it's rational, and it isn't never been tested. Why is it difficult to get this point out? We've published in the US Proceedings of the National Academy of Sciences with some leading immunologists. We've published in Science magazine, made editorials on it, talked about it. It doesn't catch. I think it's a lack of understanding among the population and even scientists. I think it's number two, a fear it may cause confusion in the public and lead to greater vaccination resistance. Thirdly, the durability is not very long. Fourthly, unjustified fear of side effects. Fifth, concerns that they may interfere with specific vaccines, but in fact, they likely will make them better. Last, without a number on it, there's no market value. They're very inexpensive. Okay, I'm coming to the end of my comments. And I wanted to make some comparisons between SARS and HIV. The similarities are related to public health and education. What about the blood test? We didn't do well with the blood test for SARS-2. The CDC was blamed, but as was kindly mentioned, I was at NIH when we developed the HIV blood test. It wasn't the CDC responsibility, as some people at NIH were saying on television, making CDC almost a scapegoat. It was a failure of all of us. In my own institute, we should have focused on that to help. But we thought it would be simple and it would be over and done with by some public health people. We didn't pay any attention to it. So we did poorly on diagnostics, and you know, there's still room for improvement, but it's much better now. I won't have time to go. You know the differences, acute virus and HIV, so I don't think there's need to go through that. That's a talk in itself, and I think you know those answers. There's sometimes a silver lining in a black cloud. There was for HIV. The silver lining in the black cloud for HIV was greater in where I sit, US and South getting together. There was far more concern of public health, for example, for Africa by the United States than ever before. There were greater women's rights. There were greater patient rights. there was intensive research in immunology, a number of positive spin-offs, and far greater tolerance for differences in sexuality that came out of HIV. Will there be one for SARS? Will there be coronavirus 2 for the pandemic? Answer right now is I don't know. I mean, I don't know. We'll have to wait a little longer. We already talked about the fourth bullet about comparing the progress, and I'd like to close this with mentioning the GVN. Yes, as indicated in the introduction, the GVN was created about 10 years ago. And this was co-founded by myself and the late Reinhard Kurth, who was director of the Robert Koch in Germany, and Dr. William Hall, head of the Infectious Disease Institute in Dublin, Ireland. I believe this slide, unfortunately, I didn't have time to change the slide. This was for the Pan American meeting with South and Central America. So I said, why it is essential for them? Well, it can't be any more essential for anyone than India. We must have Indian powerful involvement in the global virus network. Think of it from the perspective of those outside of India, like myself. You have such a big population, you have so much talent, and you do have infectious disease. We need India, and India needs the GVN. We should be kind of very constantly building this partnership. So I'm closing with this in the future pandemics. I think the government role needs to be funding and oversight. They've clearly proven that one government is not the same as another in thinking and approach. We don't know that definitely. So which government should we listen to? This is not optimum. More leadership is needed, number two, from private groups banding together, like the Global Virus Network, CEPI, the Gates Foundation, working with WHO and reporting to some governments globally. Maybe that's the UN, I don't know. We need to improve local, at least in America, I know this is where our local public health is not as strong as it should be and was. We need more local surveillance mechanisms. I don't believe in this genomic mass analysis looking for the future virus that comes into us, extraordinarily expensive and won't lead anywhere in my view. I think you need feet on the ground, you need local surveillance. And then consider, especially at the beginning of an epidemic, think you have nothing to lose. Stimulate innate immunity with an attenuated live virus vaccine. Maybe we should call them broadly effective vaccines for public relations purposes. Thank you all for the attention and giving me a few extra minutes of time. If you have any questions, I'm yours. So is there anything more you want from me, Dr. Teo or Dr. Kunuma? You want me to do anything more?
Sir, please stay with us, and we'll have a one talk from Dr. Anish, who will be talking about the Kerala situation in COVID. And after that, we would like to have some discussion after that. So you please listen to him and offer.
I will, but I want you to know from California, I have my daughter and my grandchildren here, and soon they will cause chaos in my house, and I will blame you and send you the bill. So if you keep me too long, they're not going to be good this long.
Yeah.
Okay. All right.
Anish, please. Yeah.
Who was that on the phone?
Thank you, sir.
You know, last time I couldn't put that thing back in there, but I was doing it in the wrong way. I think I had it sideways.
I'll put it back in.
Yeah. Okay.
We'll do one thing, sir. Yeah, because then we can have discussion, and then after that, Anish will talk. Yeah.
Oh, you're very popular with the phone.
Sorry, sir.
No, it's okay. I enjoy it. I like it when it's you and not me. Because I had a call right in the middle of my talk.
Yeah. So maybe we can have some questions right now. And
oh, great! I appreciate that because I can listen a bit.
Professor B. Iqbal, who is the chairman of the committee, who is advising the Kerala government in tackling COVID. Professor B. Iqbal is there. Iqbal, sir.
The expert
are some
committee had a direct discussion with Dr. Gallo about
Oh,
the.
I know,
Yeah.
Paul. We know each other.
But one doubt we still lingers in our mind is how long does the innate immunity last?
Well, I mentioned in my talk that you can't make a general judgment from data with one to another. We might, maybe you can, we don't know we can. But recently in a major publication in a very visible journal, I think it was Nature, the best guy in my mind in the world in the basic science of this problem is Mihai Netea from Romania, but working in Holland at Radboud University. He published the data for BCG and he found it's much longer than anybody thought, 6 months. No, that's as long as the specific vaccines. But we cannot conclude that that's the same for OPV or MMR. The answer is, I'm afraid to tell you, we still don't know. We've never had the, nobody has funded a trial to measure that. We don't have the money to do the trial. So we don't know, we never measured it. We don't know for the OPV, or all we can say is that, in clinical studies, there was a significant difference. I mentioned the study in Russia against flu, but there's also other data coming out. There's a study in Russia now against SARS, against this pandemic virus, and it works. Again, I haven't seen the raw data yet, but I know people who have the paper, they're translating it for English to submit it to Lancet or Nature or Science. I can also tell you of a study in Iran, and you would say that this is indicates some lasting effect. They did a study in the petroleum industry. I'm a collaborator. It's going to be published in JAMA. What they did was the women who had babies that were changing diapers that had the exposure to the OPV, vaccinated babies. Those women, compared to women who didn't have that exposure, there was a significant number. There was something like, I think 179 that got COVID in the group that weren't exposed, and 0 in the group who were exposed to OPV. But that doesn't answer your question of how long. When I talk with my colleague Konstantin Chumakov, whose mother and father, but mainly his mother, made one of the first observations. The first observation, I think, came from Singapore, and it was not with OPV, it was something else, but they made the observation that in vaccinated Russian population for influenza, it did better than the flu vaccine and was about 70%, 65% effective. So, but you didn't measure that over time. Maybe all the people were exposed early. I don't know. You can't prove it. So, but it sounds like it lasted some period of time. When I asked Chumakov, what can we say about OPV? He said, we can say one thing that was measured, how long interferon lasts. And the interferon is about a month. So you do get an interferon stimulation for about a month. And interferon is very effective against SARS coronavirus 2, this pandemic virus. So if I had a guess, I'd say minimum 1 month, probably 2 months, but it could be as long as 6 months if it's the same as BCG. But we don't have the trial that shows that. I can't answer that question proof-wise to you. So, but do I still take MMR because I can't get OPV? I'm going to take a trip to Europe. It's going to be with my wife on August 24. I can tell you, Ekbal, I will get my 3rd MMR. Okay? So like OPV. So I'm taking it. And I think I'll be protected in the 2 weeks I'm in Italy just from that. But I also have the mRNA vaccine. But I'm not going over without a specific jam of my innate immune response. At my age, and even your young age, we have to be careful. But I can't, I wish I could answer the question and tell you precisely 2 months, 3 months, 1 month, 4 months, but Mihai Netea can tell you BCG is 6 months. He proved it. Okay.
Can you also mention about the open vax movement to which you are associated with?
The what vax movement, I'm sorry.
Open vax. Or the Open Vax Foundation.
I didn't know I was associated with it, but tell me more. And I'll tell you, maybe I just agreed with their principles and I said, yes, I agree with you and sign me up. But remind me more about it, please. Can you tell me a little more? Their policy.
There is an open source foundation who work on the principle of.
Oh, you mean J. Kumar Menin's group?
Yeah.
Oh, yeah.
Two Malayalis are.
I'm sorry. I forget. There's so many things. I mean, you know, at one time I get yes. No, he's become a good friend. His son worked in our institute for the summer. We're trying to get him influenced to go into science. Well, first, let me just say, he's a terrific guy and he's very smart. And I think his ideas are good. I think his motives are good. And I think his effectiveness is good. Will he succeed in helping move this direction? Yes. I'm so sorry I forgot his that name. But you said open vax. It's open source farm, right? I mean, it's something along those, it's more broader than just vaccines. He wants to use available medicines that have been used in the past that are very inexpensive that may be going to waste. He's big for this concept. When he heard about our innate immunity meeting, an organizer invited him to a major talk. I was impressed. That's how we got to know each other. He adds to the strength of the argument because he reaches people we can't reach. I love his organization. I'm all for it. And yes, I am involved in it. I think I might be a board member now. I hope that answers your question. Okay. Anyone else? You can ask me anything, please. I mean, if you have any curiosity about anything at all that I said, or you want to challenge anything or whatever, I don't mind any kind of question, personal even.
Sir, can you look at the chat box? Chat box, there are a few questions. Chat box.
Got it. Is the immunization in childhood protecting children? With immunization, with what? Are you speaking of? What are you speaking of? Influenza, SARS-2? Are you speaking of the messenger RNA vaccine in SARS-2? Are you speaking of innate immunity? I wondered what you got to give me a little more information for me to answer the question. Be specific. You asked about childhood vaccination. Is it effective? But what vaccine are you talking about? Please. In the chat. Where is it? I can't see anymore. I don't see the clarification. Can you ask for that, Dr. Theo, to please clarify? Areas, OPV vaccines. Yeah, I don't see why not. OPV in a child? Sure. We all got vaccinated with OPV as children in America between 60 and 95. That's all we had. And sure, and we did it as children. Sure, they'll have innate immunity. They have better innate immunity than I have, I'll tell you that. That's for sure. You know, ours with age, it declines like everything else. The only thing that gets bigger and better with age in a man is his prostate gland and his ears.
Sir, another question is, what is the scope of nasal vaccines since COVID?
What?
What is the
I don't
scope
get
of
it.
nasal vaccines?
Nasal.
Nasal
Did you
vaccines,
say-
sir. Like,
You mean the flu? Wait, I'm sorry. Go ahead again.
nasal vaccines, COVID nasal vaccines. Maybe.
Oh, I don't know. Honestly, I
Like-
don't know. I have not seen reports of any efficacy data with intranasal vaccine so much. I mean, I don't know what to say. I know about flu and it works. I don't see why it wouldn't work intranasal. Would it be better? I don't think so.
Another question is, why not passive immunization against SARS-CoV-2? What are the challenges? Why not passive immunization against SARS? Passive immunization.
Passive immunization against SARS? Well, the use of therapy with monoclonal antibodies is terrific and will be coming forward. That's going to be the most important advance in SARS-2 yet for therapy. That's for therapy. You may want to know that while President Trump was not so excited about the pandemic, he was getting the monoclonal antibodies. No one else got it. So he got better very fast. They are powerful, they are good. So you can call that passive vaccination because those are monoclonal antibodies that are used, but that's therapy. You can't go around giving those to the world, that would be cost prohibitive for prevention, right? But if you were going off into an area where you thought, I have the monoclonal in my freezer, like Dr. Thayil is hiding some in his freezer. That's okay if you take it before you went into a dangerous area. Then I think you'd be pretty well protected. But we can't give that to the world, right? I mean, it would be cost prohibitive. How can you give billions of people the monoclonal antibody? But therapeutically, yes. Sick person, early virus infection, if you had access to the right antibodies, absolutely use them. I hope that's in the right vein, because Dr. Thayil, you talk very fast when you give me the questions. He's like a typical Kerala man, you speak very fast.
Regarding giving two types of vaccines for COVID-19,
Yes.
two types of vaccines, the mixing, is it more effective?
Well, let's start with the specific vaccines, like the messenger RNA, let's say with J&J or with AstraZeneca, okay?
Yeah.
Would that be more effective, the two together? I believe it would be a bit better than if you take the same one twice. Do I have proof of that? No, but it makes sense. And I've heard rumors that it is true, but that would be modest. Now you want to say, how about MMR or OPV, the non-specific vaccine, or the broad vaccines, as I like to call them. The broad vaccines, we don't have that study done, but really, how can it not be? It can't be worse. You're stimulating innate immunity, which is essential for adaptive, right? If you took them at the same time, or you took the innate immune stimulator earlier, how could it make things worse? It could only make it better, because your innate immunity is up, right? And you need innate immunity to make the adaptive immunity. When you get a vaccine with the messenger RNA, you first start with innate immunity, but you don't have it that potently, right? So, but I think you do even better. Yes, that would be my prediction. You do better. We need clinical trials. I mean, look, India and some other countries with a lot of people where there's a need, let's say Brazil. Yeah, I don't know about China, Russia. This could be really a major contribution. And you're not going to hurt anybody, and it's cheap. But this trial, we don't have the kind of data you're asking for, only your logic of your head. Now, the opinion of a booster dose, this comes from John Paniker, a booster dose. Well, yeah, John, I think it's going to be necessary. That's what I think of it. Right now, we can't say it is necessary, but in a few months' time, I bet you we are saying it's necessary.
But then how soon? How soon? After 2 doses?
I'm not, I may look like him, but I'm not God. I'm not a prophet. I cannot say how soon, but the best I can estimate is that, let's see, it's August now. We should have enough data by September, October to be able to answer that question. I think it's coming soon. I think we will be told we need a booster. To those who've been vaccinated as far back as March, let's say, by March to April, May, June, July, August, September, yeah, September, October, I don't believe we're going to have antibodies beyond that of significance, really working. They may be there, but they're going to be low. And then you're going to be basing everything on T cells. Now, if somebody comes along and shows that the T cell vaccine, that the T cell response can can protect just as well, then that's a different story. We may not need the boost, but we have no proof yet that the T cell response will be enough. Now, there was another question that came up in the chat, but it's gone. Looked like a young man. I'm sorry, I didn't get to read it in time. Can we see the chat? I can't see it anymore.
Somebody has written, should countries make COVID vaccination mandatory for all citizens?
Look, again, now I have to say again and take, I've got to be a politician here or a diplomat. I cannot force things on people. Yet, even Dr. Kunumal does not get it to drive his car without a driver's license. We all had to have smallpox vaccine. We all need a driver's license. It's required. We have politicians say, you can't demand anything of our people. On the far right in the United States, they take that position. We have governors that say that, a few, fortunately not many. The governor in Florida, DeSantis, we can't enforce things on people. We do all the time when it's necessary for public health, don't we? We used to, when I was a child, we quarantined people with certain streptococcal infections. You were told you couldn't come out for a week or whatever it was. In Venice for centuries, they quarantined people on islands before they let the boat into the harbor when they found out there was an infection on the ship. I'm sure that was done all over the world if people had any sense. So do I think this vaccine should be mandatory? Well, yes, I do. But do I think it can be done? And if I were a leader, would I say you're going to be forced to do it? That's a different question and a very difficult one because it can become explosive. So I don't know what to say. Is it proper? Yeah. I don't know why they think they can expose other people. There's a football player and the team I like in Baltimore, the Ravens. He's a well-known one. He's had COVID twice already. He said the question of vaccination was his personal choice. Okay. Now he's saying, well, he's going to talk to the players and the coaches. Now, what the hell is he talking to players and coaches for? What do they know? So we've got a funny situation, so-called people's rights. Why do they think they're going to be harmed from a simple vaccine that harms nobody at all? I don't, it's very, very hard when you think scientifically and rationally, what the heck is going on in the world? How can this be? How can you say, I don't want to get vaccinated? I'll expose myself to dying rather than get vaccinated. Or I don't believe it. I don't believe science. I believe my coaches or my football players. I don't know what they're thinking. So, you can't take a public policy stance today in America and survive it that says it's going to be mandatory. But do I believe medically it should be mandatory? Yeah, I believe medically it should be mandatory. Why should I be exposed to you who can infect me and kill me? Right? Let's think about it. What do you think? What do you guys think? This is it's not science anymore. You know the answer. This vaccine's protect. And what they're confused about and what we've done a poor job of explaining, we should have a headline. Vaccines can protect against infection and therefore, of course, against disease. But some vaccines protect only against disease because there's still a little virus that comes in. Not enough to cause disease, though. So you're protected against disease, but you can still infect somebody else who's unvaccinated who might get disease. But that's why everybody needs to be vaccinated. My God, it's not rocket science, as we say. So I don't know what we can do. It's not a science problem anymore. It's a science explanation problem, maybe. Maybe we do a poor job of getting this point across. It's not complicated. In 3 or 4 bullets, you have the story. Every citizen at least should be told, please read this and try to understand these 3 simple bullets, 3 or 4, right? What if you had something that killed instantly within 2 days that was just as infectious as the Delta variant? Would you mandate vaccines then? Of course you would. If this was 100% fatal like HIV and you died in 2 days, would you mandate vaccine? Of course, it's a matter of degree. Because then nobody could argue, right? They're scared, they'd be so scared stiff, even the politicians of such right-wing stupidity and misbehavior would make the right decision. Okay?
Yes, sir.
Oh.
Answer what to do?
Any more questions?
I really liked your answer, doctor. That was the answer. Thanks again and pray. Yeah, I think you're right. We need to pray. The person asking that question was Vivek, and he looks about 18 years old. Very young for asking questions.
Sir, hi. I'm actually 23, and
Well, you
I'm
look now. I
currently-
see your picture. You look 15.
well,
all I
maybe
know
the
is
picture
you're-
was a little bit older.
Well, all I know is you're a very handsome young man. You're lucky. That's a good beginning in
Thank
life.
you.
I can tell you, it's an advantage.
Thank you so much, doctor.
Okay, not at all. Take care. Good luck to you.
Thank you.
Great. Okay.
Shall I request our Kerala, our Dr. Harikumaran Narya? You ask.
Hello, Dr. Mohan. Can I ask a question? Dr. John Panika.
Yeah,
Just
Dr.
one
John
question.
Panikkar. Yeah,
Last
please.
question to Doctor. See, there are so many variations in the efficacy of different vaccines. How can you explain? For example, our AstraZeneca is 65, 70. They are saying some Pfizer vaccine they are claiming 95. Why so much variations in the antigenicity of these vaccines? Is it because of the host factor or the immunity of the particular person, or is it because of the vaccine itself?
No, I think.
Why so much variations in the antibody?
The answer is in the nature of the vaccine, of course. Not of course, but it's what the vaccine is. The messenger RNA vaccines, the RNA goes in and is translated within the cell. The protein is made within the cell and presented in a way that is much better for the immune system. That's a breakthrough. So the messenger RNA vaccines, nobody's going to do better than them right now. That's pretty obvious. If you're based on antibody. The other variation can be in what part of the spike is seen. Let's get away from the messenger and look at the other vaccines. One of the Chinese vaccines was Sinovac, which was just killed virus, right? Killed virus like polio, like the Salk virus and polio. It is unlikely that when you do that kind of treatment to the virus, that the spike will be in the best form to make good spike antibodies. You might get better T cell response, but you won't get better antibody. Okay, each one you can argue for an advantage and a disadvantage, but none can argue about a better approach to proper stimulating the immune system than the messenger RNA vaccine. That's a new development and it's a breakthrough. And I feel good about American innovation on this. This was good. However, when you look at the people who really did the work on the lipids, they came from all over the place, as usual in America. One is a Turk, one is a Hungarian. They're all over. So it's a diverse group of contributing people, but in the end done in America, which is the way I like to see things, that we have a diversity of people in America and a diversity of contributors, and they made a new breakthrough, and that, well, thank God for it.
Okay.
So I have a question, sir. So I have a question for Gallo. So can I ask?
Please identify yourself.
I am Dr. Sharda Devi.
Yeah.
Dr.
My
Devi,
question-
yes.
Sir,
Yes.
what is the association of original antigenic sin and COVID-19?
No, I wouldn't worry about that very much. I'm not aware that is a problem right now, and I don't think of it as so much of a problem. I kind of think that's a little bit overrated in immunology in general on a practical basis. It can happen. Maybe you might explain to the audience what you were, why you brought this up and the concern. I mean, this is like, what she means is that the original form of the antigen that the immune system has seen has been what the immune system will best remember, but with change and mutations, it may be reacting against the original form predominantly and not to change. I'm not too concerned about that so much. I don't think that's really strongly in the cards. And I also want to mention to you that the easiest, the best thing about the messengers, and I want to repeat, I didn't think these would win. I didn't think it was going to be doable. But how easy it is with the messenger to change things. Look, you can be a lawyer sitting in your desk and you see the new sequence that's dominating Delta. And you can order from companies an RNA that is adapted to that new sequence. Then you can get it produced. And then you get it in sterile form and you distribute it as the next messenger RNA vaccine, as long as you have the technology to protect it in those little particles. And then you're off and going. You do it sterile, you put it in the particle, you cover the next one. This is not going to be hard for these guys at Moderna and Pfizer. They're going to be able to adapt to anything quickly. That's where I feel good. I recognize that if I'm the owner of Moderna, which by the way is now worth more money than several countries combined, if I'm them or Pfizer, I can just relax and say, okay, new variant, press a button, let's go this way. And then you have to produce it, of course. And if you make a mistake and produce the wrong one, you've wasted a lot of money. But at this stage, they can afford to miss a few. You know, maybe Delta doesn't survive and they've made piles of vaccine against Delta. You know, it's possible. But they have no choice. They're going to have to respond. The world would be on them if they didn't, right? They can respond to this. It's not a hard change for them. And in fact, other approaches can do the same thing, not as fast, not as with the same ease, but you can take vaccines like, let's say the adenovirus, you just insert with the change sequence and start again. It's not as quick as with the messenger, not as absolute sure, but they can all be done with the rapid sequencing and mass development. I mean, some vaccines, unfortunately for the city where I work, Baltimore, and they had a producer, and things went wrong twice, and so they're going down. So, but for big producers, you need these big guys now. You need things like Pfizer. This is where they are justified. Their existence is tremendously justified. Without them, I'd be worried. I mean, AstraZeneca has done a good job. J&J has done a good job. I don't know about the Russian vaccine, and I only know the Sinovac from the Chinese vaccine. And I think I was hopeful that that would give the real T-cell response if we really needed it, because I was so concerned about the loss of antibody. But strangely, I thought the spike itself gives good T-cell response. And somebody told me, I didn't recognize it at the beginning, that the sequence of the spike protein has very good epitopes for inducing T-cell immunity. And that's just good luck. Okay.
Sir.
Hari?
Yeah, sir. You described about a phenomenon where the vaccines can act against the disease and not against the viruses. And it can be termed as a carrier state, is it not? So, carrier state, is it not?
Yeah.
The same thing can be expected in the COVID vaccination also. So what is
the same can be expected of what? I didn't get the last.
In COVID vaccines. COVID vaccine. Suppose you get vaccinated and you act as a carrier and you can infect others when you get the virus.
Yes, you can.
Yeah.
And if the other person is not vaccinated, he could get in trouble. That's why we need everybody vaccinated. But one thing, the protection against disease is also protection against the virus. That's how it works, but it's not complete. In other words, when you have a vaccine that prevents infection, it's zero, okay? But when you don't have a vaccine, the virus is this high. But with the vaccine that protects against disease, the virus is this side. So you get a little virus and the immune system controls it. That's you and me right now. We're vaccinated. We will get infected if we're not careful. But the vaccine will protect us against disease because the virus will never go very high. And by the way, that makes us less infectious to our neighbor. So it's less likely we will transmit the virus if we're vaccinated, but it's possible we will. And if the other person is unvaccinated, that little bit of virus that he gets might take off, right? Understand?
Yeah.
Yeah.
Okay.
So can we expect more mutations in such a situation where the viruses are transmitted from one body to another, not being tackled by the vaccines?
It's possible. I mean, it's not usual. When you have a low level of, if I'm vaccinated and I get infected, the virus will be very, very low level. Very hard for me to infect you, but it's possible. And when I infect you, it's going to be the dominant virus, and that's going to be the strain that I carry, and that's what you're going to get. Very likely. It can change, of course. That's what happens with RNA viruses. They change, but this Delta seems to be so efficient that he doesn't change. He doesn't need any reason to change very much right now. I mean, Delta's taken over the world, right?
Okay, thank you, sir.
Not at all. Pleasure.
Yeah, Dr. Suma.
Hi. Good evening, sir. It's an excellent session. It is very interesting to listen to it. But do you mean to say that the breakthrough infections will be, the transmissibility is less in breakthrough infections? Could it be?
The transmissibility of a breakthrough infection.
Yeah.
By breakthrough infection, you mean a vaccinated person gets infected. Is that what you mean?
Yes, yes, excellent.
Okay, well, I think any vaccinated person can get infected. If we are exposed to a high dose, we're going to get infected, but we keep it very low. And then you want to know if the very low, what will be transmitted?
Yeah.
I don't know. Yeah. Well, as I said to the prior person, the lower the virus, the less chance for transmission, right? I mean, low virus is unlikely to transmit, but it can. That's all I can say. It's possible. It's possible. But the lower the virus, the less likely the transmission until you're zero. I mean, you're not going to transmit with a few virus particles. Viruses take some numbers to be able to infect, right? I mean, the average particle number for HIV infection was estimated sometime. I mean, it's many thousands, of the particles before you can. But if your virus titer in your blood is very low and your nose is very low and your mouth is very low, it's unlikely you're transmitting, but it's possible and it happens.
Okay.
Right. And the person who gets it is likely getting a very low dose. But if he's immune, if he's older and his immune system is not so good, or has cancer or cardiovascular disease, or whatever the other problem is associated with uncontrolling the virus, that in time may take over. So you got to individualize, right? There are many variables in this story. You can't just lump all people together. But in general, if we all get vaccinated, this problem is solved. I mean, if India could become the first country in the world to vaccinate everybody with all the population you have, this would be historical and game changer for the world.
Thank you, sir.
You think your big boss will mandate vaccination for everybody?
Possible.
He's going to have a big stick. I don't know who could do that.
Yeah, Dr. Indu,
Yes, sir.
Indu, come. Indu, please come.
Dr. Gallo, wonderful talk, lots of ideas, but it's not whether the big boss will ask for it, but I think it's availability that matters. Now, most of the vaccines have gone to a few countries, sir.
Yeah,
So
I know.
the science is a star, but unfortunately, availability becomes a real issue. Availability not in terms of the resources or the capability to produce, the number of companies, pharma companies to produce it, resources for that matter in every aspect that way. If we compare the global population as such, so
yeah, I know what you're saying. and I don't mean to go back to the innate immune stimulator like OPV or MMR, but I would sure be doing it if I didn't have access to anything else. And I was doing it for 2 years. You know, almost 2 years I was taking MMR, and my wife too. Okay, so if I were you and I wasn't vaccinated and couldn't get the vaccine, I'd damn well take OPV or MMR, and I would take it every 2 to 3 months. Okay, let me say that to start with. And if you can't do that, if you think, oh no, we got to have this specific vaccine, okay, you keep waiting. You keep waiting, you're going to lose life. I would take the other and start making as much noise as you can to get, well, if it were me, I can't take a position because it's financial. So any one of these vaccines is good. They all work, okay, but to a different degree, right? So you get one of the specific vaccines ultimately, and you've got the, well, all you can do is press WHO and press the company. I mean, I don't think any company wants to not make its vaccine available. I mean, they may be told they can only do X, Y, and Z, or I mean, why would a company not want to make it available? But certainly India can afford to buy some vaccine, and you should get some, all countries that are in economic development should get some break. We feel that way. I don't think any, I shouldn't speak for all Americans, but Americans in general are not cheap. And as I see them, and majority would want to see the world vaccinated. In fact, it's in our interest, because if you are not vaccinated, we're going to have a pandemic again. We're going to always say, the world, this is a pandemic, right? Pan is everyone. We have to take care of everyone. It can't be equal. You can say it's equal, but that's not realistic, right? It's not going to be equal. If the person invents it here and has it here, their obligation is to take care of their own first, right? It's inevitable. Just as you would in Kerala, if tomorrow you invented the end of all all infectious disease, but you had a limited amount of the stuff, you would say, okay, it's going to Kerala first, and then it'll go to Delhi last, you know, so in India. So I don't, you know, it's the same human reaction, but I don't see the problem of Pfizer and Moderna massively scaling up on this global crisis. I mean, the world should be putting money into this, and America should lead that. And I think, you know, next door to you is not next door, but pretty close is China. I mean, they have a lot of money, you know, also lots and lots of money. So the richer countries in the world need to come together, make a big pot of gold, and make this thing available for everybody. And then you get people like Pfizer that, okay, increase tenfold your production. Oh no, that's impossible. No, it's not impossible. You know, start developing the beer manufacturing. So, and get help wherever you can get help. Something needs to be done. Global leadership here. You cannot be without vaccine in India. Would be a crime in all areas to me. I mean, you cannot be without the vaccine. I mean, there's no question in my mind. It works. You need it now. So, I mean, if you're not getting it, the noise has to go up. The politics has to go up. The meeting has to occur. What is the reason it's not moving even faster? It has been fast. It's been interesting movement. And some people are very proud. But if it's not getting to you now, you're not going to have to wait 5 years or 4 years or something. Some countries they're talking about, you know, be years still. I mean, my God, this is a crisis. And people have to understand, in America, in China, in anywhere where in Germany, where there's a lot of money, you have to understand that one island with the problem, who's free to travel, is a danger to the world. So if you view it selfishly, you need to take care of the world. That's where we are. I mean, I don't know what else to say from a scientific angle. I'd be afraid if there's one place on Earth that still has it, because it's going to come back. And then they'll create new variants, and our vaccine won't work for it, and we will get caught by surprise, and a lot of people will die again, and we'll have to start over with the vaccine. I mean, that's what's going to happen. You can predict this will go down, disappear, we'll be happy. Then all of a sudden, in 2 years, 3 years, it emerges again and forcefully. And we'll be dealing with this all the time because we didn't deal with it right the first time.
agree. It's sometimes disappointing to see from the scientific point of view, when science has made such a big contribution, which has made a big breakthrough, the political leadership across the globe have to, I mean, they have to hold hands together and come up. And
Well,
until that comes up, it's
yeah.
really sad with these mutations happening around, the transmissions happening, and from one point to another, right? The alpha, after the alpha, the delta from some other country comes back, and I mean, there's a surge somewhere. When that's happening, even after months, even months after, the effective vaccines have come up with the new platforms and all. That's what, more than the science, I think now there's a lot of, other equity, equality, and other issues. Internationally, globally, it's everybody's concern, as you said. Thank you. Thank you.
I thought if ever there would be coming together, like they used to make the movies, crazy movies, the aliens are attacking the world, right? The Earth, and all the Earth people come together to fight. Well, these are the aliens attacking the Earth, only they're little, they're viruses. And we can't seem to even come together in this, So if the Martians did come, there being no Martians, but if they did come, we wouldn't unite. It looks awful. I mean, there's never been this magnitude of stress with China and US. I can say that for sure. I mean, this is really not going in the right direction for sure. I mean, less and less communication, more disrespect back and forth. I mean, it's not, not going to make things better. I don't know what to say.
The hypothetical situation, suppose sufficient vaccines are not there and the countries are not joining together, what will be the natural history of this virus? Will it disappear after many years, or maybe the whole human race will be wiped out?
Oh, no, it's theoretically possible. If something like Delta were more efficient in killing, it's possible that you'd get, devastation. And maybe you select for people that are, more resistant, and the vaccines would be available for some. Some people might be wiped out. But, the answer lies in the vaccine, and the natural history of this is to continue. This is to continue, and it'll continue, and new variants will emerge, and the vaccines probably can control it. But if you're not vaccinated, more will come, more variants will come. And if you don't get the vaccines, ultimately there'll be pockets of places that'll harbor virus. You'll forget about it. We won't be vaccinating because this is going to take you boosting, and we won't boost anymore, and then it'll come back again. And that it's hard to exactly predict, but I don't anticipate that this is an easy future unless we do vaccinate everybody, and with the right vaccines, and as fast as we can.
Even though the disease started in China, with the data available, we don't know. Not many cases are there. People are not dying. Why is it so? Is it a truth or a lie, or we don't know what it is? What could it be?
What's the question? Why people aren't dying in China?
Yeah, China, even though the disease started, it has got more population than India. But
well, I mean, they have a totalitarian government that said you will stay in your room, or you get arrested. So, it's a little different in most democratic nations. It's pretty hard to tell an American if you go outside, you're going to be arrested. I mean, I have friends that go back and forth to China, and they had to quarantine for 2 weeks in a hotel. It's very difficult to tell an American you're going to sit in a hotel room for 2 weeks, right? They're going to go out. They're going to go out, they're going to get arrested. So in China, they don't go, they stay in the hotel. So they quarantined people. They just did it. You talk about mandatory, they mandatory that you don't go out. So, I mean, I think that's what they did. They controlled it, but virus is creeping back in China now, that. So we're hearing stories now that, that it starts again a bit in China. Okay. So, but I think the difference is in the nature of the government in this, for this angle, when there's a true crisis, you know, what they said, the best form of leadership is a benevolent dictator. The problem is most dictators are not benevolent. The second problem is benevolent dictators, once in power, power corrupts and they become non-benevolent. So, you know, what's to do? The best system invented, of course, is democracy. Of course, republics, of course, the way things are going. But when you have a crisis, you can't compete, and they'll smile and think that proves their superiority. Yeah, they can. Oh, I don't want to get into it, you know. I'll get into philosophy and politics and all that, and you know better than I do. So I have my opinion, but I wish we were able to get closer to China. And I think the Trump administration and Xi's administration, the current president, haven't helped. So, you know, that's one of the problems. We'll see. But don't think China is free from this. They're not. And is it a lie? I don't know what they're saying there, that no one dies. Their vaccine is certainly not as good as the vaccines that came out of the States. You know that. Everybody knows it now. But they didn't need the vaccine as much because they quarantined people strongly. They were very strong in isolating the population. And they did a good job, I think, in the tracing. But we really don't get the detailed information, so it's hard to comment. It's hard for me to know. Right? How do you know? How do I know in China? Yeah, sure. I'm saying goodbye to someone. Okay. All right.
Just one question in the chat box. Does the virus to be more virulent always, can it be less virulent and then slowly die down? Is it possible?
Yes, it's possible. Surely.
That is our prayer.
It doesn't have to mutate a bit worse for people. The problem is sometimes it's trying to find ways to circumvent the immune system, right? And so you think the greater chances is worse because to circumvent the immune system means it produces itself more. And the more it produces itself, the greater the harm to us if it still retains its ability to latch onto that receptor, which causes trauma to our bronchial tree, our pulmonary system, and beyond. That's a common receptor. It's a common protein, that ACE2 business that is. So if it keeps mutating to escape immunity, it usually is replicating more efficiently, and that's dangerous. Okay.
Thank you, sir. Thank you.
Okay.
Do we have any more questions?
Can we go for the next session?
Time for the next session. Time for me to see my grandchildren.
Yeah.
Thank you, Gala, sir, for excellent speech and excellent interactions.
Thanks all. Good luck to everyone. I hope we can work together in the future.
Sure.
And I don't mean the future next year. I mean now, soon. You got to fight for these vaccines. I mean, no question.
The Institute of Virology, which has been established in Thiruvananthapuram, on your the suggestion, we hope it will come out with many of these studies, and then we will come out with more results.
We don't say this casually. We need Indian involvement and leadership. You need to be participants. We need to hear from you about a suggestion for a board member from India, somebody that you think is prominent, that could be helpful to the GVN internationally, somebody who could sit there and be, you could be proud of me as a GVN board member. We don't need all Americans. We don't want all Americans. We one time had 3 Chinese people on the board, no Indian. We don't have the Chinese members right now. But we're looking for people now, no more for the money. Before we were desperate for money, GVN really was desperate. We had to do things like board members had to donate, no more. We now have had some gifts, of significant gifts. We don't take money. See, we don't have government money. We're not under any government. That's a great advantage for bringing Chinese in, Russians in, but it's a disadvantage funding wise for us. But if the United Nations or WHO get together and realize the importance of this and put some annual budget for us, it would be great. But meanwhile, by working hard and relating to pharmaceutical companies and relating to philanthropists, we've been able to not only survive, we're now doing rather well. So we're okay. But think about playing, don't be shy, play a stronger role, suggest somebody for the board among you, say, ooh, we have somebody, he doesn't have to know medicine and biomedical science, could be know nothing, could be a professor of geology, could be a politician, could be a wealthy person, could be somebody that you just respect a lot and you think has influence. Let me put it this way. No one in the GVN would have refused Gandhi. He wasn't very rich.
Correct.
You understand my point. It can be broad. Sorry. It's not COVID, it's allergy. It's hot here. It's hot here, more hot here than it is in Kerala. And the air conditioning makes me dry.
And we are in a webinar, so there is no question of infection.
Yeah, there you won't get any infection from me. Don't worry, I feel strong. All right, take care, everyone. I have to go now.
Thank you, sir. Thank you.
Bye now.
Thank you.
Bye.
Namaste. So now we'll continue. Jai Krishnan, Anish, yeah. Anish, sorry for keeping you waiting for a long time, but then it was worth.
The previous speaker, Gallo, asked about Kerala. Where is Kerala? Kerala is the southern and western part of a tiny piece of land. Due to its climatic and human factors, international travel, increased mobility and density, it is a hot spot for any pandemic in future pandemic. Recent example, the COVID-19 first landed in Kerala within 1 month. And Nipah virus, South Indian visitors in Kerala in 2018 and H1N1 also in 2019, within 100 days from March to June, it reached Kerala. So about the future COVID-19 and other pandemics, the next speaker is Dr. Anish. There is no need of introduction. He is a non-public health expert in Kerala, and also he is a forefront leader of the People's Science Movement in Kerala. He's working as Associate Professor and Department of Community Medicine, GMC Tirunelveli. Mr. Invite Dr. Anish for his presentation. Dr. Anish, please.
Respected Chair, Dr. Jai Krishnan, sir. Am I audible, sir?
Audible.
Respected Vice Chancellor Mohan, sir. Dr. Robert C. Gallo, respected Rajmohan, sir, and other teachers and friends. I may be rushing through my slides because I know that we are in shortage of time. Is it visible?
Yes, visible.
Visible.
This is our COVID-19 dashboard. Okay, so I'm not going to the numbers, and I'm just showing. This is the dashboard prepared by H1N1 Center in Trivandrum, and you can see that Kerala is having a very different color. That means currently Kerala is contributing to 50 to 60% of total number of cases in India, and we have got a reason for that I will discuss shortly. And again, this is from the same dashboard. It is about the death rate. If you just think about death, Kerala is paid in color. That means Kerala is reporting the lowest number of death rate, somewhere around 0.5%, and one of the lowest in the world. And if you look at vaccination, you can see that Kerala is not performing. So actually, the situation is not very bad. So in India, we have got a dedicated program to vaccinate more these union territory regions and some special areas where disease was rampantly spread. And Kerala is having a sufficiently large number of vaccination compared to an average Indian state. And if you just look at the data, you can see that more than 1.5 crore of people has given at least one dose of vaccination. So that is about vaccination. If you look at the epidemic curve, you can see some differences in the epidemic curve of India as well as the epidemic curve of Kerala. This is the epidemic curve of India. You can clearly see two waves. And that is why we are thinking about a third wave, and we are speaking about second wave. Second wave was very much higher or something like that. So that is actually an Indian situation that we have got very clearly two waves. And 11th September 2020, that you can see the date. And on that day, India reported the maximum number of cases during the first wave. That is somewhere around 97,000. You can remember that as 1 lakh. That means India reported 1 lakh cases on the 11th September 2020, which was the peak day for the first wave of India. You look at on the same day what was happening in Kerala. Kerala was reporting only maybe 3,000 cases. Only 3,000 out of 1 lakh that India was reported. Only 3%. That means you can see that Kerala's peak was delayed and the curve was very much flattened. And that is applauded for Kerala that in first wave, this more than like a wave, it was a plateau. And you can see that so many people were accommodated during the wave of first wave. So even if there is so many numbers were there in Kerala, actually we were capturing very much high numbers, and it was really what is a textbook definition of flattening of the curve. And if you go for the second wave or the first wave, the lowest number after first wave was reported on 11th February 2020. In all India, the total number of cases were less than 10,000. We can see what was happening on the day. On that day, Kerala was reporting somewhere around 5,000. Out of 10,000, more than 5,000 is reported by Kerala. That means 50%. So Kerala's, if you look at the situation in Kerala, during the peak day or peak of the curve, Kerala may report less than 10%. But even between the curves, Kerala used to report more number of cases. And it is actually a feature of the flattening of the curve that is happening in the state. That means we are accommodating more number of cases in a very long duration of time so that we can spare our resources. So that is an advantage that Kerala is making. If you go for the second wave, the peak day was on 6th May 2020 for India. More than 4.14 lakh cases were reported. Okay, on that day, if you look at Kerala, you will see that there is again peak was slightly delayed, but that was not to that extent where the peak was delayed in first wave. That we have got the reasons that we know that it is because of Delta, and Delta is not giving that kind of a luxury for the communities where it is spreading. So in the second wave, you can see it is 42,000. Again, that's almost 10% of the Indian situation. And this is on the last days. It is on 3rd August. And you can see that India is reporting 42,000 cases, and Kerala is actually reporting around 50% of cases. So you can see that if you look at the Kerala's curve, you can see that there is a flattening of the curve is taking place, and more people are accommodated during the longer duration of the curve. So it is there in Kerala that we are reporting more number of cases even between two curves. But suppose today also we have got around 22,000 cases reported. Suppose this 22,000 or this 20,000 is happening on the peak days of second curve, along with the Kerala was reporting somewhere around 45,000 cases on maybe 6th May. Suppose this 20,000 cases were also added to that. Anyway, our system might have collapsed. Actually, what is happening is Kerala has taken infection from the peak days of the second wave, and now we are allowing infection because we cannot go for strict lockdown because of the economic and social reasons. So we have got an advantage because now this 20,000 can be accommodated in our hospitals. That is one major advantage, that our hospital, we have good spaces in our hospitals. And second advantage is we have got time. That means from May to August, we are actually getting maybe 3 months. During the 3 months, the vaccination has taken from maybe 20%. First dose of vaccination has reached more than 50%. And we are going to get the advantage of more people vaccinated. And a significant number of this proportion is breakthrough infections. So what is the plan of Kerala that we can do? Is from the ICMR seroprevalence survey, it is evident that in Kerala, there are much number of people are yet to be infected. So we have to allow some kind of infections and we have to vaccinate. The vaccination will not have a foolproof protection against Delta because Delta will make some kind of breakthrough. And we have to accommodate those breakthroughs. But if the breakthroughs are not end up in severe hospitalization or death, and I think we can afford that. So in Kerala, we are going to face number of infections in the coming days also. But as the vaccination is happening, and if you are able to vaccinate maybe 80% of our population, we may end up in a large number of breakthrough infections and we may translate. Maybe what is happening in UK is maybe replicated in Kerala, but we do not have that kind of high vaccination compared to UK. And this severe kind of COVID infection may be translated to something like a common flu that we can think of. We will not allow, or we cannot allow the rampant Delta variant as such and get a herd immunity out of the rapid spread of Delta variant that has happened in the North India. So that is the situation of Kerala, and that is why Kerala we are getting more number of cases because definitely we have got more number of people to be infected. And you can see that 100% of cases now is Delta, and even in breakthrough also it is Delta. This is the granulation of our vaccination. I am not going to detail, and it is the same picture that we have seen. And as I have already mentioned, the future of COVID-19 in Kerala may be immunity because of vaccination versus immunity because of infection. Certain infections will take place, maybe 10 or 20% of people may be affected during we are getting the enough vaccination, or we are getting time to vaccinate enough number in our population. And we may be having sustained infection for maybe a longer duration of time because we have got a large number of people to be infected in the state. And definitely there will be breakthrough infections are also going to take place in our stage. And I am just speaking about some other pandemic potentials that Kerala can face. Other corona or influenza viruses, Kerala is actually prone for other coronaviruses and influenza viruses. This is actually a publication that is quoted very widely. It is a Nature publication, and it is saying that if you account for the reporting, you will see India, especially you can see the Kerala part, we are more prone for infections from wildlife, that is including influenza and corona. If you look at the hotspots that is available in all over the world, you can see that in Kerala is actually a hotspot for infection from wildlife. If you go from domesticated animals, may not be an issue. But if you maybe third is what is this one? Okay, drug-resistant infections. Again, Kerala is not much an issue. But if you look at here, again, we are seeing that Kerala is a red spot. That means that is D is for vector-borne pathogens. That means we can have large outbreaks of corona or influenza. That is one possibility that Kerala is threatened because of this publication, and it is actually a widely quoted publication, and you can see in detail about the publication. So that is one thing. One is vector-borne diseases, and second one is corona or influenza-like illness that we are going to face in future. Again, there is another Nature publication on 2017. Again, you can see that this is the first picture is unadjusted, and if you adjust it, you can see that the next corona or influenza can be there from India, including that from Kerala. That means along with the southern China, which is a cradle of influenza or some with the coronaviruses, again, India can also contribute much to the coronavirus. So it is not sometimes India or Kerala can be contributing the next pandemic that we cannot deny. That is a possibility. And if you look at Kerala, you can see that there are very frequent bird flu infections among birds, partly because we are able to capture the infection, but partly because we are more prone for this kind of infection because of we have got a large population of migratory birds, and migratory bird and local bird interaction, and so many things are happening. So we are actually prone for that kind of new influenza illnesses also. This is about Nipah that you can, I'm not going to detail because, but you know that the studies which is analyzing Nipah virus infection among bats, and Kerala is supposed to be a hotspot because in India, I think Kerala has contributed the maximum number of infected bats in the study that was conducted. And you can go for the publication that I am giving. So if you look at for the mosquito-borne diseases, and I have already said that we are more prone for mosquito-borne diseases and corona and influenza-like illness from wildlife. So if you look at this mosquito-borne disease, you can see that in 1994 we have got JE outbreak. In 1995, there is a resurgence of malaria in Trivandrum, part of Trivandrum city, that is Variagura, after maybe 25 years of absence of very large clusters of indigenous malaria. In 2003, we have got dengue started and we have got multiple outbreaks. And 2017, we faced a large outbreak because of dengue. And from 2006 onwards, we have got chikungunya, and we may face a very large outbreak of chikungunya in near future because of the absence of or reducing herd immunity. And we are facing new infections like Innate, and in Trivandrum now we have got Zika, and many people are afraid of something like yellow fever can happen, or it can visit Kerala. So we are always in threat of mosquito-borne diseases, and we have got some other very rare diseases we may be knowing that Casimir forest disease. Until recently, we were not thinking that Casimir forest disease is a concern for Kerala. But from 2015 onwards, we are getting many cases from Wayanad as well as from Malappuram. And you can see that Kerala we have got more cases of real cases of KFT from Kerala. And from the southern part, the serological analysis among animals were showing that presence of KFT even in South Kerala. And we do not have much serological data from human population from South Kerala. That may be the reason that in Indian map, the South Kerala is not depicted. So many issues are there from Kerala, and I'm actually trying to summarize all these things into this particular slide. And we have got a climate change issue. Because of climate change, the diseases like leishmaniasis is rampant. If you personally, I know that I am following the pattern of this Phlebotomus argenteus in Kerala. And now it is very widely present even in urban areas. Once it was actually very rarely present in our villages and towns. It was only isolated from tribal area. Now it is rampantly present everywhere. Urbanization is contributing to so many mosquito-borne diseases, that including that is mediated by Aedes. And our waste management is actually contributing so many diseases. Land use is actually very important, especially for the diseases like Strep syndrome. We have got mosquito-borne diseases, leptospirosis. You know what is happening after flood syndrome. And we may face recurrent floods, and we may have large outbreaks of leptospirosis. And hantavirus, it is actually very interesting to study hantavirus, because in India, we negate that we do not have Handa, but it is less likely because in all Asian states, we have got Handa except maybe India. And maybe we are negating a part of our leptospirosis infections that is happening in our state, maybe because of hantavirus. So somebody, I think, if you are interested in infectious diseases, you can take up the issue, because hantavirus is a very big concern. And Strep, as I have already mentioned, leishmaniasis, okay, that is also mentioned. And we are prone for waterborne diseases also because of climate change, because drought is also a very big issue. And domestic animals, we are prone for many diseases like brucellosis. We have got recurrent outbreaks of brucellosis in our domestic animals, especially Manuthi and all we have identified. And anthrax is also, there is sporadic occurrence of anthrax. And bovine tuberculosis is another concern, because as human tuberculosis is coming down, very drastically, and we are getting more number of ovarian tuberculosis, which is resistant to treatment. So in Kerala, we have got many risks for impending pandemic, or just we can become a very a field which can pandemic can be generated because of the climatic condition, typical tropical country, and we have got high animal-human interaction. Population density and distribution is a particular pattern. High population density is widely distributed across the maybe length and breadth of Kerala. And population mobility is so high that if a pandemic is generated in Kerala within days, it can even reach to any part of the world. And demographic structure is more towards the elderly, and it can actually have that kind of an impact. Maybe killing power of a disease may be more because of the elderly or the structure of the demography. And we have got high comorbidity that we are facing in case of COVID also. The comorbidities can be associated to the impact of any pandemic. And immigration, that is a very important concern. We have got high immigration, especially from other Indian states. And you can see that the surveillance mechanism in other Indian states may be poor, and we can get infections from other states because of the high immigration. Lack of diagnostic facilities was a concern till recently. Even now, it is a concern. Most of the diseases outbreaks were diagnosed elsewhere from Kerala. But now I think we are trying to build that gap. And definitely there is a lack of research. So that is a very big concern that we are not actually studying what is happening in Kerala and what can happen in Kerala. The infectious disease research is actually like a very high lacuna that is there in Kerala. And this is all about my presentation, and I was pushing through because we do not have much time. Thank you.
Thank you, Anish, for your future forecasting presentation. Then this is the time for questions. One question, you can look at the chat box. What are the future plans for this emerging disease? Any plan? One question.
Actually, we do not have a real plan. We have got some piecemeal plans. For example, after Nipah, our medical colleges and private hospitals were distributed with kits that can diagnose many viral diseases, including maybe Nipah. And we are under threat of so many, almost all diseases I have mentioned is viral diseases. Now we are building up the institute and virology labs and all. But I don't think that we have got that is an organic system in place to relate all these things.
Any other questions or discussion?
One question. Can I ask?
Sir.
Hello?
Sir, I can hear you.
Sir, you can ask.
Do we have data, like you compared India with Kerala, do we have comparison between districts? Because, just in a general perception, I think some districts had been consistently reporting very low number of cases. And is that something to do with the density of population, or for one thing? Secondly, do people there in those districts, I'm referring to Kasaragod, Wayanad and places like that, Idukki, maybe Alleppey, is it also possible that people have such employment which do not require them to commute from home to indoor spaces, workspaces, which are, meaning this is something which may be more with Kerala. There are a large number of people in Kerala who leave their homes, work outside their homes, and most often in indoor spaces or crowded places, unlike predominantly rural agrarian societies, especially North India, Rajasthan, Uttar Pradesh. I do not know whether when community spread becomes a reality, when we have reservoirs of virus inside the homes, then the transmission between one bubble to another bubble becomes more frequent when there are people moving outside their homes and then gather during daytime in indoor spaces and then get back. I just want, this is just a random thought. I just want your comment on this. Thank
Sir,
you.
I think your question has got two parts. One is about data and second one is related to people's mobility.
Correct.
And data, generally we have got three types of data. One is the administrative data, purely administrative data. That means some government officials collecting through government systems. Second one is the research data. And third one is something like a registry kind of thing. That means it has got a quality of a research data and it could be used for administrative purposes. And if you go for administrative data, we have got very good administrative data collection system in Kerala. And we have modified our IDSP and we are using that platform very well in Kerala, especially for communicable diseases and all. But definitely it has got so many lacunae as you have pointed out. In some districts it may be working well and in some districts it may not be. And sometimes the administrative, as it is administrative data, it is under administrative control. And the person who want to reduce the number of infections, just in a phone call, you can reduce the number of infections. So that kind of an issue will be there for an administrative data. So research data is very, very minimal in Kerala. It is not at all promoted in Kerala. Not only for infectious disease or any other things, the researchers are not very much promoted in Kerala. That is second one. The registries are almost absent. And we may be having some cancer registry or something like that. Otherwise, so we do not have sufficient data. That is even in COVID, people or government is promoting, generating administrative data, and the other two things are not at all promoted. That is actually a sad thing that we can see even in COVID. Regarding people mobility, I think the people's mobility has contributed much to the economic prosperity of Kerala. Especially people who are moving to Middle East and people. That may be one of the reasons that we are enjoying some kind of an economic prosperity. That may be having some kind of collateral effect on controlling of disease or building our health systems and all. So I don't think it is a good idea that because of the spread of communicable disease, we can keep people inside their home, or we can just go back to an agrarian society or something like that. I don't think it is feasible, or I don't know. I think others can comment on that.
Dr. Purushothaman, you have raised your hand. You can talk.
My point is, when we encounter one problem, all of our weapons and surveillance will be directed to that. That's what we are hearing. And maybe people from Malappuram may be remembering from 2019 January onwards, there were around 180 or so encephalitis cases. Many of them were comparatively benign, recovering. We had experiences and a few cases were investigated. Few of them showed enterovirus grown. There were few cases of myocarditis associated. And by the time Corona came, there was no investigations done even when the doubtful cases of similar episodes happened. Every investigations and surveillance was totally directed to Corona. That's what is happening hereafter. Just like the non-communicable diseases are ignored, when there is an important communicable disease, we'll be forgetting about the other communicable diseases which are still prevalent. Another thing is, recently for the last few weeks, DPT is not available. DPT shortage is there. When we are behind the vaccines, Corona, there is shortage. Nobody is bothered about the shortage of the DPT. In the neighboring country, Afghanistan, Pakistan, polio is increasing and we don't give much importance to polio. So when we plan forward, we are focusing on one thing and maybe the other important controlled diseases are ignored. That is very important though. So when we plan in the future, there should be a system which is maintaining the surveillance and the diagnostic aspects of the existing disease also. Few of the diseases are there in Calicut, Malabar area. Few cases of Shigella are the killing type of, it's recurring every year or every third year. There are many cases of atypical manifestation Shigella. So we need to investigate that. This encephalitis part, which is happening again in Malabar, the Nipah happening. So why these sort of illnesses are more and more concentrating in Malabar area? So there's a need for research for all these things. So everything, all the resources are now concentrated on one pandemic. That is the situation. What is there in the news will be behind that. That should not be the situation. These things should be always, especially the vaccines. Our routine vaccine, we are going behind, and maybe other infections are also likely by the time we control it becomes the endemic situation.
I think this is hugely important. I think maybe later on we need to sit down and discuss that. You made a very, very important point. For more than a year now, other infectious disorders and non-communicable disorders are getting a bad deal. If this state of affairs continue, we will be seeing much more undoing of what we have gained over the last 20 years. I think this is a serious public health challenge, which is not, it's very silent now. I think the moment it comes out, the scale will be huge. And I think we will be, I am tempted to call it as a triple burden. We talk about double burden, re-emergence of acute infections when you have a NCD burden. This pandemic is something like a triple burden. You have emerging uncontrolled infectious diseases in this part of the world. Then you have NCD and then pandemic. As you rightly said, when pandemic came, everything was secondary and we are going to pay for it. And I'm sure Vice Chancellor and everybody heading the departments, please take note of this very important statement. I think we need to have a session, non-COVID, on addressing these two issues. Thank you very much, Dr. Purushottam.
But just one point, last year some data has been published saying that the overall mortality in Kerala was less. Any explanation?
I think that data itself was not very dependable because deaths can get reported very late. But then we need to look at this. If that is true, I would tend to believe that that will be compensated in the next few years by NCDs and other infections, as was pointed out. I don't see any logic in believing that that is the case, except it would have controlled some respiratory infections and which are not that fatal.
Accidents.
This is my take on
this. This excess data analysis was published by a journalist, Stukmani, but the data sources are the vital registry system that is in India. That is actually a respected data source. So that data is dependable. But as Shadi sir was telling, there may be a delay in reporting.
Yes.
But for the comparison between states, if there is delay in Kerala, definitely there will be a delay in Tamil Nadu also. There may be a delay, maybe more in Tamil Nadu. So if we compare the state, we can use that data. And maybe for 2020, the delay period was almost over. So this data shows in 2020, there is actually a reduction in death in Kerala. That may be because of the collateral advantage of using masks and all. And the COVID deaths were actually very less. And the other advantage was more. But in 2021, as far as now, maybe first 6 months or so, we have got some excess death that is it's very minor compared to most of the Indian states we do not have a data in the public space. This lady was analyzing data which was available in public space, and they found that the excess mortality was much less in Kerala. It's somewhere in maybe less than 5% or something. But in Maharashtra, in Madhya Pradesh, it was somewhere around 2 lakhs. So essentially we are performing, we may be doing a good job. Definitely the death rate will be much less in Kerala, but maybe it will take time to convert it.
Dr.
Ajit Kumar is waiting. Ajit Kumar.
Yeah, Ajit, my doubt is actually an extension of the question which we discussed now. Dr. Anish, actually we are doing fine, reasonably well. There is no doubt about that, and there is no controversy about that also. But what we should compare is not with Bihar or not with even Tamil Nadu. We should compare with ourselves. That's the problem which Kerala has. Our mortality per day is somewhere between 100 to 150 per day. Now today is more than that. That means in a month we are going to have somewhere around 4,500 deaths. Should we be happy about that? Because we are saying we are plateauing the curve. That's true. But our curve is going to be very long. So on a longer curve, 100 or 150 deaths per day will be a cumulative large number. So, and as the curve goes longer and longer, the system will get affected. So should we plan for that also? And also what was actually the highest number of death per day or death per month Kerala faced during the second wave? So just would like to have your opinion on this.
Actually, as you have rightly pointed out, this is actually a real concern and we are experiencing large number of deaths every day. But I'm not sure what is happening inside that black box. That we have got almost, as far as I know, we have got around 5,000 deaths unreported during the early phases of the pandemic. Is it the death that is reported now, maybe in a graded manner? Is it a reason for maybe having one more than 100 or 150 deaths every day? I do not know exactly. But if this number corresponds to the actual number of COVID cases in Kerala, definitely it is a concern because we have got more than 50% of vaccination. And out of every day 20,000 cases, why you are getting 150 deaths is actually a real concern. I should completely agree with you. But we have to look to the details or the granulation of the death reporting, whether it is corresponding to this time or is it having some kind of an adjustment government is making, I do not know, sure. So that is the real concern about that.
Thank you.
Any questions? Sir Mohan sir, for remarks.
Something which Robert Gallo said, why nobody is giving BCG or polio? Is it possible for us to do that? Is there any?
Sir, the problem is a policy decision, and the two problems as I can see, there is two problems. One thing is still we do not have a quality evidence that polio or BCG is going to work. Because in Australia, during the first phase of the outbreak, along with the other vaccines were developed, they were trying to use BCG as an option, along with just a substitute for COVID vaccine. And that trial was withdrawn because of lack of evidence. So a real, maybe a real primary data we do not have on that. That is one thing. Second one is a policy thing. For example, if you go to government of India or government of Canada, and if you are telling that, okay, we are not able to produce enough COVID vaccine, let us try BCG. It is very difficult to take it up because people may, or these policymakers may think that it is a failure from their part that they cannot provide COVID-19 vaccine. So I do not know how much. So I think Gallo is trying to build that an evidence base so that we can try that in a cohort and we can see that innate immunity is working or something like that. I think he wants a space. Definitely that will not work in Europe. In US, definitely it will be working in areas in a third world country. and he wants to generate that kind of an evidence. That is why, that is his intention. That is what I think. So it is actually a matter of debate, but to get it cleared from government will be very difficult.
Sir, can I add to that?
Yeah.
Yes.
Yeah. Actually, the BCG or MMR makes some non-specific immunity. For example, in dermatology, we give MMR and BCG for the treatment of warts, and a few warts fall. But even by the argument of Dr. Gallo, he says it works only for a month or maybe a month or two. And we need a huge infrastructure, manpower, resources, etc., to administer it regularly every month. So as a public health program, it will not work because we can use the same amount of resources and manpower and infrastructure for a lot of other things. Like, what we discussed is even non-COVID is being ignored because of either COVID or non-COVID. In peaks, we manage only COVID. In non-COVID, when by the time we come down from COVID, again, we have another peak. So in that stage, one more vaccination program will be a huge burden, which may not be worth that effort. That's what I felt.
I think there is no more questions. We have reached 9:30, even though the original plan is 7 to 8:30.
8:30.
So Jagarshan will wind up.
Sir, wind up.
Okay.
Concluding remarks.
Thank you so much. It was a very exciting program, and Robert Gallo really inspired all of us. In spite of his, he is so senior. He has been in the scene for so many years, but still he acts so young, and he is so inspiring. And it was a great session. And in fact, Dr. M.V. Pilla was supposed to join this session. Then he has just sent me a message that he could not join because he is stuck in an airport. And he has said that Dr. Gallo has written a book, and all of us should read that book. I will just just mention it, right? The autobiographical book of Gallo is Viruses, and it has been translated in many languages, and an edition in Malayalam will come soon. That's what he said, and it's a very inspiring book. All of us must read that book. That's what he has just sent me a message. And thank you, Anish. Excellent presentation, and I thank Jagarshan for moderating the session in an extremely well. And I thank all the participants. Now we are finishing the 4th day, and there is one more day to go. Please be there tomorrow also. Tomorrow, Dr. Shyam Kutilil will be talking, and he is the man behind this whole session. It is with his cooperation only we could arrange this whole session. Thank you. Good night.
Thank you, sir. Good night.
Thank you, sir.
Thank you, sir.
Good night, sir.
Good night.
Thank you.
Good evening, ma'am. May I ask one question? Hello. Hello. Actually, we are going to wind up, and I'm sorry for asking a repeated question.
Wind up. Over.
ഹരി സാർ എല്ലാ ദിവസവും സെൻസസ് എടുക്കുന്നുണ്ടല്ലോ.
ആരെല്ലാം ഇവിടെ ഇങ്ങനെ ഇരിക്കുന്നു നോക്ക്.
അത് നാളത്തെ സെഷൻ കൂടെ പറഞ്ഞിട്ട് കഴിഞ്ഞിട്ടേ ഞാൻ നേരത്തെ ചോദിച്ചതിന്റെ ഉത്തരം പറഞ്ഞു തരണേ.
ഏത്?
ഇന്നലെ ഞാൻ ചോദിച്ചില്ലേ, ഇന്നലെ അല്ല മിനിഞ്ഞാന്ന്. അല്ല, ഇടയ്ക്ക് പിന്നെ ഹോസ്റ്റ് എൻഡ് ചെയ്താല് ബാക്കിയുള്ളവരവിടെ നിൽക്കുമോ എന്നുള്ള ചോദിച്ചില്ലേ?
ഹോസ്റ്റ് എൻഡ് ചെയ്താൽ എവരിതിങ് വിൽ ഗോ ഔട്ട്.
ശരി, ഞാൻ ഒന്ന് ചോദിച്ചോട്ടെ. ആക്ച്വലി റിപ്പീറ്റിംഗ് ആണ്.
Madam, everybody has left, madam. All those who you expect to answer has left.
ഹലോ മാം, നമ്മള് ഇപ്പം റോബർട്ട് ഗാലോ സാറിനോട് നമ്മൾ ചോദിച്ചല്ലോ ട്രാൻസ്മിഷൻ കപ്പാസിറ്റി ഓഫ് വാക്സിനേറ്റഡ് ഇൻഡിവിജ്വൽസും എത്രയുണ്ടെന്നും, അതുപോലെ any country made vaccination mandatory to all people, and then whether the virulence of COVID vaccine reduced after a certain period. Appo actually adine onnude clear aaki taravo? Actually, I was not able to follow because of network issues. That is why I am asking again.
നാളെ ചോദിക്കുന്നതായിരിക്കും നല്ലതെന്ന് തോന്നുന്നു അല്ലേ സർ?
അതിന്റെ എക്സ്പെർട്സ് ഇവിടെ ഇരിക്കുമ്പോൾ പറയുന്നതായിരിക്കും നല്ലത്.
Madam, can you come up with the